Geometry students. Today we're going to be looking at the very last set of information going towards the Unit 3 test, and that is going to be on slopes of parallel and perpendicular lines. Okay, so this is kind of back to what we started on, talking about parallel lines earlier in the unit. We've kind of gone off on this crazy tangent talking about graphs and all that. Now it's kind of time to come full circle and look back at what the equations have to do in order for lines to be parallel or perpendicular. Okay, so let's take a look at our objectives for today. Stated objective, student will discover the properties of slope for parallel and perpendicular lines. Our language objective, that's what we're going to be doing on our assignment. We're going to demonstrate the ability to apply properties of slope in order to determine equations of lines that are parallel and perpendicular. And your essential question for the day, can I determine slopes for parallel and perpendicular lines? Now, this is probably the only new material that you have seen in this second half of Unit 3. Okay, so pay close attention on this one, and as always, press pause anytime you need more time to get something copied down, and then hit play when you're ready to move forward. Okay, so let's get started. Now, kind of the critical question of what we're looking at today is, what is it about a line that makes it behave in a graph the way that it does? Hopefully you have an answer to that, because it's kind of hand in hand with what we've been working on the last couple of days. What is it that controls the overall behavior in a graph? Well, it's the slope that controls that. Slope tells the graph whether it wants to move up from left to right, or whether it wants to move downward from left to right, whether it wants to rise up in a hurry or rise up very slowly, whether it wants to be horizontal, whether it wants to be vertical. Slope gives the line that information. Okay. Therefore, it is the slope values of two lines that will force them to be parallel or perpendicular. Two different lines will have two different behaviors, and if they are behaving in certain ways with respect to each other, it's possible they might be parallel or perpendicular within a graph. Okay, so first thing, if two lines have the same slope, let's think about that for just a second. Same slope means they are rising at the same speed as each other. They are running at the same speed as each other. That means they will be parallel to each other. Okay, so having the same slope value pretty much is kind of to be expected with being parallel. If you get to thinking about rising and running at the same speed, obviously the lines will never hit each other. On the other hand, if two lines have slope values that are negative reciprocals of each other, okay, if two lines have slope values that are negative reciprocals of each other, then that is going to make the lines perpendicular to each other. This one's a little less common sense than the other. Okay, so it's going to take us a little bit of explanation to understand what this just said. And the first thing we probably need is an explanation of what negative reciprocals means. So let's get a definition for that guy. Negative reciprocals means this. If you were to take one fraction and turn it upside down or flip it, and then change the sign of that fraction, meaning we're going to go from positive to negative or from negative to positive. Okay. If that ends up making it look like the other fraction, then you have negative reciprocals. Okay. Now, let's look at an example. What do you know about the following two lines? Well, we have two lines here. They are in good standard intercept form, slope-intercept form. We know they're in slope-intercept form because the y value is isolated. Remember, that's very important when you're reading slope-intercept form. Make sure your y value is isolated. If it's not, you absolutely do not try to read the slope or the y-intercept. So here we have two lines, y equals 2x minus 5 and y equals 2x plus 13. What do you know about the slope of the, or what do you know about the following two lines? Well, first off, their slope values are the same. And we know that because we look at the coefficient in front of x when we're in slope-intercept form, and that is our slope. So in this case, we have two slopes, or two lines, that both have the same slope, which would be 2 over 1. If the slope values are the same, that means the lines are parallel. So that's what you would know about these two lines. Now, where they cross the y-axis is really not relevant. Okay, to be parallel, nobody says they have to be close to each other. Nobody says they have to be far away. We simply say they have to have the same slope value. Let's look at another one. What do you know about the following two lines? Okay, once again, our lines are in slope-intercept form, meaning the y is isolated. And again, we would not want to try to read slope or y-intercept unless we were in slope-intercept form. And our equations are y equals 3/4 x minus 5 and y equals negative 4/3 x plus 13. Okay, so what do you know about the following two lines? Well, this one's not nearly as easy to see. Okay, so we're going to check and see if perhaps they are perpendicular to each other. The rule says to take one slope value. Now, it does not matter which line we get this slope value from. We're just picking one of them and stealing its slope. So I'm taking the top one, and its slope fraction is 3/4. If you take one slope value and turn it upside down, so 3/4 would become 4/3. And then you change the sign of that fraction. Well, the sign is currently positive, so we're going to reverse that to make it negative. The rule for negative reciprocals said if you take one slope and turn it upside down and change the sign, if that makes your fraction look like the other fraction you were comparing to, which would be the slope from the second line, then you have negative reciprocal slopes. So we did the little procedure for negative reciprocals, take one slope, turn it upside down, change the sign, and we found the slope that belongs to the second line. If that's the case, then these lines are perpendicular to each other. Once again, where they cross the y-axis is not important. As a matter of fact, perpendicular lines very, very rarely are going to cross the y-axis at the same point, so it's expected that they are going to cross at different y-intercepts. Okay. Example. What is the slope of any line that is parallel to the line 2x plus 3y equals 4? Okay. Now this is a trap question, not a trick question, but a trap question. They will throw questions like this at you on the test on Thursday, I would imagine. They're going to dare you to try to read the slope out of this equation exactly as it is written right now. So 2 will definitely be a choice on the test. However, it is not the correct choice. We need to see the equation in slope-intercept form. Well, it is obviously right now not in slope-intercept form, so we're going to have to convert it. So the equation 2x plus 3y equals 4. To get in slope-intercept form, we want the y value to be isolated. That means we are going to move everything else away from y. So the first thing we should do is let's get those x's out of there. You have positive 2x. Let's subtract 2x to both sides of the problem. That will move the 2x's over to the right. And now we have 3y equals negative 2x plus 4. Continuing on with trying to isolate y, we currently have 3 y's, but we don't want 3 of them. We only want 1. So how do you move the 3 but leave the y? They are currently being multiplied, so we'll do the opposite of multiplication, which is division. Now be advised, when you divide, you need to divide all of the terms by the same value at the same time. Okay, so we're going to divide all of those terms by 3, and when you do that, we're going to end up with 1y, which is what we wanted. We now have a slope value of negative 2/3 x, and we have a y-intercept at 4/3, or 1 1/3. Okay, so how does this help us? Well, in order to determine the slope of any line that was parallel to that line, we needed to know the slope. Now our slope is negative 2/3. So what would the slope of any line that wanted to be parallel to this line be? Well, it would have to have the same slope value, so that slope would be negative 2/3. Okay, so there is your answer. In order to be parallel to this line, we're going to have a slope of negative 2/3. Okay. Let's look at it again. What is the slope of any line that is perpendicular to 2x plus 3y equals 4? Well, if you're paying attention, okay, then this is the same equation as the last example. Okay, but once again, you need to see the equation in slope-intercept form. Okay, so we already did that, so I'm not going to go through the math again. I'll just write it down again. All right, so in slope-intercept form, our equation is y equals negative 2/3 x plus 4/3. If we want to be perpendicular to this line, we need a slope value that is a negative reciprocal of this slope value. Okay, so let's run it through that procedure. We're going to take the slope that we have, which is negative 2/3. We're going to turn it upside down. The actual mathematical term for that is reciprocate. We're going to reciprocate the fraction. So that will make it negative 3/2. And then we will change the sign. So it's a negative 3/2, which will become a positive 3/2. Take the slope, turn it upside down, change the sign. That is negative reciprocals. So the slope of any line that wants to be perpendicular to the line that they gave us is going to have a slope value of rise 3 and run 2. Okay? Example? There is a line passing through points negative 5, 3 and 5, 9. They want what is an equation of any line that is parallel to this line, and what is an equation of any line that is perpendicular to this line. Okay, so there's just one more step that we're going to take on this example. We're going to have to figure out what's going on with the slopes, and then we're going to have to write an equation that would allow those slopes to participate. Okay, so these questions are based on the slope of the line. You need to calculate that slope. Now, the problems we've seen before had basically been giving us the equation or giving us the slope, but as we've seen in recent days, that information is not always given to us. We may have to run through our formula. So let's do that. We've got our 2 points, negative 5, 3 and 5, 9. Our first strategy is, of course, to label our points x1, y1 and x2, y2. We're always going to write down a formula if a formula is applicable, and in this case we do have a formula for slope. Slope is y2 minus y1 over x2 minus x1. Now we're going to install the values into the slope formula. y2 is 9, y1 is 3, x2 is 5, and x1 is negative 5. We will simplify in the numerator and simplify in the denominator, and then check to see if the slope fraction itself will simplify. The numerator, 9 minus 3, is 6, and the denominator, 5 minus negative 5, you have that double negative in there. That's like a plus positive, so 5 plus 5 is 10. So our slope is rising 6, running 10. We will reduce this if possible. Both of these are even numbers that can actually be reduced down to 3/5. So this is the slope of the line that we have in this particular problem. Now, that's not the answer to any question that they asked. They wanted to know an equation of any line parallel to this one and an equation of any line perpendicular to this one. So let's take a look at that. We have a slope of 3/5. Any line that is parallel to this line must have the same slope. It's got to rise and run at the same speed. So our equation of our line would be y equals our slope, which is 3/5 x, and then plus wherever. Okay, we said that parallel lines don't have to cross the y-axis anywhere near each other, so we can make up any y-intercept that we want. So I'm going to make up negative 19 or positive 19 for no particular reason, and that is an equation of a line that is perpendicular to the line that they were talking about. Okay, the second half of the problem, what is the equation of any line perpendicular to this one? Okay, well, to be perpendicular to this line, you must have negative reciprocal slopes. So we need to figure out what the negative reciprocal of 3/5 is. So we're going to start off with our slope fraction, which is 3/5. We're going to turn it upside down, which would make it 5/3. And then we are going to change its sign, so it will go from positive to negative. So any line that wants to be perpendicular to this one must have a slope value of negative 5/3. So when we plug that into an equation, y equals, our new slope is negative 5/3 times x. And once again, to be perpendicular, nobody said it has to cross the y-axis at a particular place, so we can make up any y-intercept that we want. And this time I made up negative 32 for no particular reason. Y equals negative 5/3 x minus 32 is perpendicular to the line that they gave us. Now, one more example here. Okay, I'm going to leave this one open-ended. I want you to give it a try. Okay, and I'll give you a little guidance here in just a moment. Write the equations of two lines. Both lines will pass through points 2, -1. One of the lines will be parallel to 4x minus y equals 3, and the other will be perpendicular to it. Now, that's a lot of information to consider there, and we have not looked at an example that goes deeply into this. Okay, so you're not going to necessarily, everybody's not going to know really how to do this one, but you can do parts of it, so I want you to at least get it started. Okay, so look at the information that just appeared on the screen. In order to find the equations, we're going to need to know the slope value of the line. Okay, but if you notice our equation that we have, it is not in slope-intercept form. So you're going to have to figure out slope-intercept form in order to know the slope. So you can do that in that upper left box there. The two boxes beneath that ask what would the slope need to be in order to be parallel. Well, once you know what your slope is, we ought to be able to tell what slope it needs to have in order to be parallel. And then underneath that, once you know what your slope is, we ought to be able to tell what kind of slope does it have to be perpendicular. The equations over on the right-hand side are going to need a little bit more help, so I will help you with that when we get to class. But please do figure out the slopes and the parallel slopes and the perpendicular slopes and bring that information to class with you tomorrow. Okay, one final thing, as always, write your summary, jot down any questions that you have about the material that you need answered, and always keep in mind your essential question. Can I determine slopes for parallel and perpendicular lines?